Welcome to lecture 3 of this module. Today we will learn about object-oriented programming using C++. This is today's agenda. We will start with a brief review of what we learned so far. Then we will have an introduction to important object-oriented programming concepts in C++. Today we will study about inheritance in detail. As the name suggests, inheritance is about inheriting from parents class. It's a very interesting concept which permits code reusability. Next, we will study about method overriding. Method overriding allows a child class to provide a specific implementation of a method, which is already provided by one of its parent class. Finally, we will conclude our lecture today with a brief introduction to virtual function. So, let's see a brief review. We have discussed the benefits of object-oriented approach. It tends to model the real world in a more complete fashion than traditional procedural approach. The model is based on objects rather than on data and processing. Not only that, object-oriented development makes code more maintainable and easy to reuse code in new systems. We have studied about objects. Objects are the fundamental building blocks of applications in an object-oriented approach. Each different type of object comes from a specific class of that type. And we know that a class is a blueprint or a set of instructions to build a specific type of object. We have seen the structure of class. Then finally we learned about constructor, a special type of subroutine to create objects from a class. Similarly, destructor, which is a special member function of a class, which is executed whenever an object of its class goes out of scope or whenever the delete expression is applied. Now, today we will study about object-oriented programming in C++. So the object-oriented programming language is divided into 4 major concepts. We will start with encapsulation. It is the mechanism that binds code and data together. It binds code and data together and keeps them safe and away from outside inference and misuse. We have seen about data encapsulation and hiding. Next, abstraction. Abstraction refers to showing only the essential features of the application and hiding the details. So it shows only the essential features of the application and hides the details. We know that using access specifiers, the variables are hidden from direct access. Which access specifiers? Private. Next, inheritance is the technique used in object-oriented programming where one object acquires the properties of another object. So here one object acquires the properties of another object without redefining in order to create well-defined classes. Next is polymorphism. The basic idea behind polymorphism is that the compiler doesn't know which function to call at compile time. So it is done at runtime. The retrieving of code and the type of objects while the program is running at compile time and runtime is polymorphism. So these are the important object-oriented programming concepts. So today we will study about inheritance. Inheritance is the most powerful feature of object-oriented programming. After classes, inheritance is the process of creating new classes called derived classes from existing base classes. So, in the process of inheritance, we create new classes by using another class as reference. The class whose properties are inherited is the base class. The class which inherits is called the derived class. So we create derived class by using base class as reference. The derived class inherits all the capabilities of the base class, but it can also add refinements of its own. The base class remains unaffected in this procedure. So this is the inheritance relationship. The derived class, this is the derived class, is obtained from the base class. This concept permits code reusability. So inheritance is an essential part of object-oriented programming. It is a big payoff because it permits code reusability. So once a base class is written and debugged, so we have a base class which is written and debugged, it need not be touched again. Using inheritance, it can be adapted to work in different situations. Reusing the existing code not only saves time but also increases the program's reliability. So the base class which is already ready, debugged, can be used for another implementation adding some features specific to the derived class. This permits reusability of the base class. So let's see some example. We know that a derived class inherits member functions of the base class. So this is a derived classes. These are all derived classes. They will inherit the member functions of the base class. The derived class can be used anywhere the base class is expected. However, a base class cannot be used anywhere the derived class is expected. So if you see one example, here animal is the base class. It has certain features which are common to all the group. Say some number of legs, some number of tails, etc. Now we have certain derived classes from this base class. Dog, cat, rabbit. So each of these have their own characteristics. Consider age, weight, anything. So the point to notice is all the dogs here are animals. That is, they will exhibit all the features of animals and inherit all the member functions of animal. But not all animals are dogs. But this animal doesn't mean that all the dogs are animals. So the base class is animal, which include dogs, cats, rabbits. The derived class is say dog, a smaller, more specific set of animals. So here in base class we have feature A and B. In derived classes we have here feature C, another features, another set of features. So each derived class will have its own set of features which is specific to it. So continuing with this example where we have a base class animal and derived class dog. So this is the class animal. Then we have class dog, public animal. So we know that this is the base class and this is the derived class. Then here we use a colon. This colon indicates that the dog class is based on the animal class. That is, the derived class, this is the derived class, is based on this base class. This particular heading indicates that the animal is a public base class. So when we use the public word here, it indicates that it is a public base class, that is a public derivation. With public derivation, the public members of the base class become public members of the derived class. So to make it clear, we have the derived class dog, the base class animal, and the access specifier here is public, which means that it has the derived class has full access to the public members of the base class. So if you declare an object of class dog, if you declare any object of this class, it will store within it the data members of the base type. So all the data members of this class will be stored in this derived class when you use a public access specifier. And also it will inherit the methods of the base type. The functions also will be inherited. Thus a dog object can access these functions get legs and set legs from the animal class. And we can also add feature specific to the dog. So suppose here we have added these functions. They are specific to this derived class and then we can use print details. Now we will study about a new access specifier, that is protected. You already know, we have already studied about access specifiers private and public. So a member function of a class can always access class members whether they are public or private. So inside a class, whether it is public or private, we can access all. But an object declared which is external, we know that an object is specific to a class. So when an object is declared externally using the dot operator, it can only access the public members of the class. It is not allowed to use the private members. Now, this is true if we don't use inheritance. When we are using inheritance, the question that occurs is, can member functions of the derived class members access the base class? So without inheritance, we can have an object of the class which will be able to access only the public members and not the private members. But with inheritance, we have derived class, base class and derived class. So will the derived class objects be able to access the base class members? The answer is that member functions can access members of the base class if the members are public. So if the members are public, the derived class will be able to access the base class member functions. But they can also access if they are protected. So if the access specifier is protected, the derived class can still access base class members or member functions, but they cannot access private members. So, but for any external class or function, it acts like private member and thus preventing from accessing it. So when we have an external class or function, the protected access specifier acts like a private member and prevents them from accessing it. Only the derived class can access the functions or members. So a protected member can be accessed by member functions in its own class. This is one example. We have an object A. It can access only public members of A, and member functions of class A can access both private and public members. So inside this they can access both. Member functions of this can access both. An object which is defined externally can only access public members. This is what we discussed just now. That is the access specifiers without inheritance. But In case of inheritance, we can access only the public and protected member functions. So if you see this object, it can access the public of this one and the public of this one. Again, we have protected member functions which can access protected and public member functions of the base class. So a protected member can be accessed by member functions in its own class or in any class derived from its class. It cannot be accessed from functions outside these classes. Protected member cannot be accessed from functions outside these classes. It is not accessible to external objects or functions. So this is what we want. Otherwise, if we make it public, it would be accessible by any function anywhere in the program and eliminate the advantage of data hiding. In this figure, if you see again, without inheritance, object A can access only public members of A. It cannot invoke private members. Similarly, member functions of class A can access both private and public members. With inheritance, however, member functions can access members of the base class if the members are public or if they are protected. They cannot access private members. Similarly, member functions which are public can only access member functions which are public of the base class. To understand this, let's see an example. We have a base class C1. This is the base class C1. This has a private variable A, protected variable B, and public variable C. So consider three cases. So case 1, we have a derived class. This is the syntax of derived class which we saw just now. So C2 has access to B and C because it is a public access specifier. It has access to B and C, both protected and public variables. So if some other class derives C2, it can also access B and C. But from external functions outside, only C is accessible as only that is public. From any external, it is only C which can be accessed, but from inside this class, both B and C are accessible. Another case where we use protected access specifier. So here C3 has access to B and C. Again we have access to B and C. That is, any class deriving C3 can access B and C as protected. But since it is a protected inheritance, only this derived class can access these two members. Any external cannot access any of these variables. In this class, we have private inheritance. So there, both become private members of C4. So here both are private members. No function which is outside C4 can access these variables. So just review once again. Here, this is a public inheritance. So whatever is inherited here can be accessed outside, provided it is public. So we have inherited B and C because they are protected and public, but only public variable can be accessed outside. When we have protected, both the inherited variables are protected. Only a derived class will be able to access the protected variable. From outside, none of them is accessible. But when it is private inheritance, no function can access these variables from outside. They are both private to this class. So this is the usage of access specifiers in inheritance. This table summarizes the access specifiers in C++. So if you have access specifier public, it is accessible from own class, accessible from derived class, and accessible from objects outside class. But when we have access specifier protected, it is accessible from own class and derived class, but not from objects outside the class. That is protected. Private means it's accessible only from own class. It is not accessible to derived class and not accessible to objects outside the class. So it gives one more layer of security. So the moral is, if you are writing a class which at any point in the future as a base class will act as a base class for other classes, and any member data in that base class will be used by the derived classes, then it should be made protected rather than private. So when you write a program, if you make a base class, instead of making the variable which may be used later private, make it protected. So this ensures that the class is inheritance ready. Also, there is certain disadvantage when we make a class member protected. They are lesser secure, obviously, than private members, because any derived class can access protected members of your base class. It may lead to corrupted data. Also, remember that the base class remains unchanged through all this, even if other classes have been derived from this. So this is about access specifiers. Now, derived class constructors. So we have a counter class here. This is a class counter. We want to decrement the count. So we want to derive a new class from this class without modifying this class itself. So new class count dn is created, which adds a decrement operator. So if we create an object of this class count dn, when we create an object of this class, it is initialized to 0. So here we have no constructor, but still when we use an object, it is initialized to 0. The derived class, this is because the derived class uses an appropriate constructor from the base class. So even though here no constructor is defined, the derived class will use a constructor from the base class and initialize any object to 0. So since there is no constructor in the count dn, the compiler used the no argument constructor from counter class. So what happens? The question is, what happens if we want to initialize count dn object to a certain value? So now we did not initialize anything, but now we want to initialize it to a certain value. So can we use the one argument constructor in the counter class? No, we cannot use this argument in the derived class. The compiler only substitutes a no argument constructor from the base class. So we have to write a new set of constructors for the derived class. Suppose this is the new set of constructors. So if you see this no argument constructor, there is a function name following the column. This causes the count dn constructor. So this is constructor of this class. This calls the constructor counter in the base class. The base class constructor is called before the derived class constructor starts to execute. Similarly, in the one argument constructor, this count dn calls the corresponding one argument constructor in the base class. So for a derived class, if you want to initialize to a certain value, then we have to define such a way that it calls the constructor from the base class. And if there is no constructor in the derived class, it will take the default constructor in the base class. Now, we come to a concept overriding. As you know, derived class will contain all data and functions declared on itself as well as the shared contents from its base class. Thus, we call a base class function from derived class itself. Sometimes the derived class may have completely different implementation for a function that is already defined in the base class. So in this case, we need to override the base class method so that when functions call happen from derived class object, it will call the modified implementation. To do this, declare and define a function with same name as in base class. This concept is called overriding. So when we run the program and call the method using derived class object, the compiler will try to see if the function is present in the class. If yes, it will be called. If no, it will search if that function is present in the base class. If so, it will call that. That is, derived class function will get precedence over the base class. Thus, if we have overridden, then that will call the derived class function. Here, we are showing a real life example where overriding helps. So this is the base class, class person, where private data members are there. These are the private data members and public functions are there. So this function print details prints the person details. Now the derived class student will inherit. This is the derived class student from class person. It will inherit all the functions of this class. So this class also has function print details. The derived class also has same function. So whenever this function is called in this class student, it will print student details. Even though in the base class it consists of different implementation, it prints what is specific to the derived class and it is called in the derived class. This is function overriding. This is called function overriding. The function print details is overridden here in the derived class. Base class object will call base version of the function and derived class object will call the derived version of the function. This is function overriding. Now, there can be different types of inheritance and different levels of inheritance. So this is the most basic type of inheritance. In this type of inheritance, one derived class inherits from one base class. It is the simplest form of inheritance. Multiple inheritance. In this type of inheritance, a single derived class may inherit from two or more than two base classes. So here, one class is being derived from two base classes, public A, public B. Then we have multi-level inheritance. It is the inheritance hierarchy wherein derived class acts as a base class for other classes. So B is derived from A and C is derived from B. So this is the derived class for A but base class for C. So there will be a chain of inheritance with a class derived from only one parent will have only one child class. Then we have hierarchical inheritance. In this type of inheritance, multiple derived class inherits from a single base class. From a single base class, multiple derived class are inherited. That is, this is the inheritance hierarchy wherein multiple derived classes inheriting from one base class. Then hybrid inheritance reflects a mixture of two or more types of inheritance. So we are deriving from same class and again deriving to one same class. This is different types of inheritance. Now we will give a brief introduction to virtual functions. A virtual function is a member function that is declared within a base class and redefined by a derived class. So in inheritance relationship, the derived class gets access to protected member data, thereby achieving reusability. The derived class is getting access to the protected member data. But the objects in the base class also uses member functions belonging to the child class based on the user's choice. So here we are saying that the objects in the base class may also use member functions belonging to the child class at runtime. This is done by a virtual function and overriding it in the derived class. So a derived class function can be read by a object in the base class. To create virtual function, precede the function's declaration in the base class with the keyword virtual. When a class containing virtual function is inherited, the derived class redefines the virtual function to suit its own needs. So why virtual functions are needed? Suppose you have a number of objects, okay, and these objects are of different classes, and you want to put them all in an array and perform a particular operation on them using same function call. So, for example, suppose you have a graphics program which includes different shapes, say a triangle, a square, and so on. So, each of the classes has a member function draw that causes the object to be drawn on the screen. Completely different functions are executed by the same function call. When you say draw a triangle, different function will be called. Draw a square, different function will be called. So if the pointer points to a square, the function that draws a square is called. If it points to a triangle, the triangle drawing function is called. All the different classes of shapes must be descended from a single base class. So these are all descended from a single base class. And the draw function must be declared to be virtual in the base class. So in the base class, we declare the draw function as virtual. So in the derived class, when you have a triangle class, you can call that particular draw function where triangle is drawn. And similarly. So in this way, the base class runs a different function at runtime depending on the type of the object which is instantiated at runtime. We will see more about virtual function in detail in the next set of slides. So, we will end this lecture here. We studied in detail about inheritance today, the base class, the derived class, the syntax used. Then we studied about the access specifiers and their importance. When we need to access any member data of the base class in the derived class in future, we should make it protected instead of private. Then we saw that the constructor used in derived class calls the base class constructor before execution. So derived class constructor calls the base class constructor. If there is a modified implementation in the derived class for the same function, there is a modified implementation in the derived class, then method overriding will call the function present in that derived class. If it is not present in the derived class, then it will be called from the base class. That is method overriding. Then we saw different types and levels of inheritance and how do we use virtual functions to redefine a function in derived class. We will continue in the next lecture from here. We will discuss about polymorphism and overloading. Thank you.